Hello, AP Physics 1 students. I'm just going to talk over a few of the details we didn't quite get to go over in class. So in class, we developed the equation for work. We derived it from combining Newton's second law and kinematics, and we got W equals F delta X cosine theta. And we noticed the peculiarity that in the equation we have two vectors, force and displacement, and yet for our answer for work, we're getting a scalar answer because there is no directionality to work. Certainly work can be positive or negative, but it doesn't indicate a directionality to it. So if you do 10 joules of work and you happen to push the object to the left, and you do 10 joules of work and you happen to lift the object up, no matter what, you're tired by exerting an amount of energy of 10 joules. So there is no directionality to work. So it is strange that we have vectors in the equation, and yet we're getting a scalar as an answer. So let's do a little bit of a sidebar here in our notes about this. We're actually going to see this pop up a number of times throughout the year. The real equation for work looks like this, where that is not a multiplication dot in there, that's something different. This is a way to multiply two vectors and get a scalar as an answer. This is known as the dot product. Maybe some of you have seen it before in some of your math classes. This is a new operator. Even though it looks like a multiplication dot, it is something different. It's an operator that tells you to multiply these two vectors and get a scalar as an answer. And so the generic way to do a dot product is if you have vector A dotted with vector B, that is the actual verb for it, A dotted with B. Here's the definition. A dot B equals the magnitude of A. That's what we mean by putting A in absolute value bars. So the magnitude of A times the magnitude of B times the cosine of the angle between them. And you see this follows the exact same pattern as what we have here in the work equation. A vector times the cosine of the angle between them, giving a scalar as an answer. So again, a dot product is a way to multiply two vectors and get a scalar as an answer. And we are going to see this a number of times throughout the year. So let's now just go back to what we've done here in problem 2. In problem 2, we'd analyzed problem 1. We looked at all the different forces acting on the 5-kilogram object, and we tallied up how much work each one did. And in the end, we put it all together to get the net work. And by just adding together all the amounts of work by the individual forces, we got the net work, which should make sense, right? 120 minus 40 and then 0 and 0 for a net work of 80 joules. And if you look at how we derived the equation, we really didn't derive the equation for work, we derived the equation for net work, which is really the work done by 1, and the work done by 2, and the work done by all the forces acting together. So let's just define this as a new equation. We'll say W net work, equals F1 delta X cosine theta 1, plus F2 delta X cosine theta 2, plus dot, 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 so on and so forth, for all the different forces that are acting on the object. You basically just find the work done by each, add it all together, and that gets the net work. We will define W net as this new term called network. Network, you know, like ABC, CBS, NBC, network.